Class 5 of Power Electronics for Diploma Electrical students of KPT Mangaluru. Now we will see the characteristics of the SCR. So here you can see the forward blocking state. It is written here. So even though this is the voltage axis, this is the current axis. When you apply voltage, SCR will not conduct. A small leakage current will flow. When you reach breakover voltage, the SCR will conduct heavily. You can see another figure. A small leakage current only will flow. At breakover voltage, SCR conducts. When it conducts, voltage becomes around 1 volt and current increases. Current value will be equal to applied voltage by load resistance minus 1 volt, which is the SCR drop. This is with gate is equal to 0. Gate current is 0. When you apply gate current, some gate current, say 5 milliamps, SCR will conduct before 500 or 400 or 230, whatever it is, the breakover voltage. So before the breakover voltage, it will conduct, and again it will go to the conduction state. If more gate current is applied, it will conduct earlier. So this is forward blocking state and this is forward conduction state. So here it is set Ig3 greater than or equal to Ig2 greater than Ig1. Ig1 is 0 because it is forward breakover voltage. Next it is said here reverse condition. When anode is made negative with respect to cathode, SCR is reverse biased. So during reverse bias, there will be small leakage current because during reverse bias, SCR will not conduct. During reverse biased means when this voltage is negative, make this opposite, ulta. Now this will be negative, this will be positive. So junction J1 and J3 will be reverse biased now. Junction J2 will be forward biased. This is now negative, this is positive. So these two will be reverse biased. The middle one, J2, will be forward biased. Same thing, SCR will not conduct because two junctions are reverse biased. When the reverse biased voltage is increased, we will reach a condition where the SCR conducts heavily and current is limited only by the load resistance. This is destructive and SCR will get damaged. That is why we should never apply full voltage or reverse breakdown voltage to the SCR. So even though there are 4 modes, forward blocking state, forward conduction state, reverse blocking state and reverse conduction state, we are not going to use reverse conduction state. See, forward blocking, forward conduction, reverse blocking, reverse conduction. So we should not go beyond this point. And there are other certain terms which we will study now. So there are different figures are given for characteristics. You can write whichever is easy for you in the examination. So Practically, as said earlier, we are going to fire SCR using gate triggering method or by application of gate. Now, SCR is a latching device. That means once the SCR is fired, gate loses the control. That is, even after the removal of gate current, SCR will remain in on state. In case of transistor, you need continuous base current. You know that when base current is applied in a transistor, collector current will flow. When base current is applied, collector current will flow. That you know. But in case of SCR, once only you need gate current. Once the SCR is fired, you can remove the gate current. SCR will remain in on state. See, this is power circuit. This is control circuit. You will forward bias the SCR with the voltage lesser than breakover voltage. If you apply breakover voltage, it will conduct immediately without help of gate current, and it is also risky, as said earlier. So you will apply here voltage lesser than breakover voltage in the forward direction. Now if you give gate current, SCR will become on, and then remove the gate current. Even if you remove the gate, the SCR will remain in on state. But there is one condition, that this anode current or main current or load current or SCR current should be more than at least some milliamperes. That is called as latching current. So latching current is the minimum value of anode current required for the SCR to remain in on state as soon as SCR is turned on and gate signal is removed. So see, it is a minimum anode current required to maintain an SCR in on state immediately after the SCR has turned on and gate signal is removed. So you need certain anode current. Suppose, say, what happens sometimes, say, you will keep here, say, something 2 volt and here something, say, 100 ohms, and you try to fire the SCR. So 2 volt by 100 is how much? Around 20 milliamperes. So load current itself will be around 20 milliamperes, very small. In such cases, the SCR will fire when you give gate current, but when you remove the gate current, this will go off again. This latching current depends upon the individual SCR. It will be in order of milliamperes. Normally it is not a problem, because you will not apply around 1 volt here, 1 or 2 volts, but in certain cases it has to be considered. The only way, once the SCR is fired, it will be always on. The only way to switch off the SCR is to bring the anode current lesser than holding current. So holding current is another current, another value of anode current. It is a minimum anode current required to maintain an SCR in on state while gate is open. Suppose, say, you fire an SCR. Okay. Once you fire the SCR, say this will become, say, around 1 ampere. Then you remove the gate current. SCR will remain in on state. Then To switch off the SCR, you have to reduce this, or you have to increase the load resistance, or you have to break the circuit, else SCR will remain on. So you reduce this value to 1 volt or 2 volt, or you increase the load resistance a very high value, which is actually not practically possible. So you may decrease this value if this is a variable power supply. When you decrease this value beyond, say, some 15 milliamperes, say, the SCR will go to off state. It cannot maintain very low value of current. So this 20 milliamperes of anode current or the main current is called the holding current. So holding current will be slightly lesser than latching current. It is easy to remember. Alphabet L is next, that is you see A, B, C, D, E, F, G, H, I, J, K, L. H comes first, L comes next. So L is senior, or L has more weightage. So IH will be lesser than IL. This will be a little bit lesser than this one. Ideally, for an SCR, both IH and IL should be 0. Ideally, it should be 0. Ideally, leakage current also should be 0. But practically, leakage current will be some microamperes or nanoamperes, and holding current and latching current will be in order of milliamperes. And gate current, which will be always in milliamperes, it also has some ratings. There is limit. You cannot give 1 ampere or 2 amperes of gate current. SCR will get destroyed. So the manufacturer specifies the limits of gate current, and we have to design the circuit such that those conditions are satisfied. Hope the characteristics is explained properly. In case students have not understood this, kindly give me feedback. I will explain once more.